So number 6 from the vertical motion worksheet. An object is dropped from a certain height and strikes the ground with a velocity of negative 49 meters per second. So we're standing up here on the cliff and we drop the ball and it hits the ground at 49 meters per second sometime later. From what height was the ball dropped? How long did it fall? So in our terms, we want to find S0 and find time. All right, well, let's start with what we know, which I guess doesn't feel like a whole lot for this problem. S of t, put it over here. S of t is, let's see, we're at 49 meters per second. So negative 4.9 t squared plus v0t plus s0. Although it said it was dropped, so we didn't throw it down or throw it up. We just dropped it, so that one's gone. V of t is negative 9.8 t. That one's already gone, and the derivative of a constant is 0. So v of t is negative 9.8 t. And I think this is what's going to help us, because we know that down here at the bottom, the velocity is negative 49. I don't know how long that took, but I can figure that out. So 49 divided by 9.8. So t equals 5 seconds. That was question B. And we need to find S0. So we need to figure out that distance that it traveled. Well, we know at t equals 5, we know v was negative 49, and we know s was 0, because that's where it hits the ground. So let's see if we can put all that together, probably in this equation. So 0 equals negative 4.9 at time equals 5. V0 was 0, so that was gone, plus S0. So 4.9 times 5 squared, 122.5 meters. So we answered them in the opposite order they were asked, but that's okay. We got them both. So that's a good question, because that one wasn't as straightforward as most of the others. You had to kind of work backwards on that one. Number 8 on the same worksheet. An astronaut stands on the edge of a cliff and drops a rock. I really just like drawing people on the edge of cliffs, dropping rocks. He observes that it takes 3 seconds for the rock to land. So down here, t equals 3. This is related to number 6, but we have different information here. How high is the cliff? So in our language, that means find S0 if gravity is 28 feet per second squared. Okay, well, almost always, you've maybe noticed, I'm going to write, whoops, not S0, I'm going to write S of t and V of t, and then I'll figure out what I know and what I need to know. So S of t is 1/2. G, it would have been better if they'd have labeled that negative, because we know gravity is always pulling us down. 1/2 negative 28 t squared plus V0t plus S0. Another one where V0 is 0 because we dropped it, or the astronaut dropped it, so we don't have to worry about that part of it. So S of t is negative 14t squared plus S0. because we don't know this height. What do we know? At t equals 3, it's at the bottom. But no, yeah, that would work, because s of 3 equals 0, because we're down at the bottom. So 0 equals negative 14 times 3 squared plus s0. 14 times 9, 126. And we were in feet, so 126 feet high if he was on Venus. This will go quicker for the others. If he was on Mars, it's kind of the same thing, except that gravity was 12, so that would end up being negative 6t squared plus s0. So s0 would be negative, whoops, not negative anymore, 6 times 3 squared, 54 feet. And then you could do it for the moon as well. But it would be the same process. And based on the pattern, it would be even less. Is that right? Yeah. Because the bigger the gravity is, the further it can fall in 3 seconds. On the moon, not much gravity, so it takes it a longer time to fall. Number 4 on the vertical motion worksheet. A white ball is dropped from a height of 100 feet. One second later, a blue ball is dropped from a height of 75 feet. Right, make the picture right there. That's the blue ball from 75 feet. Which one hits the ground first? All right, I think a couple ways to work this, but I think the easiest way is to just find how long it takes to hit the white one, for the white one to fall, how long it takes to hit the blue one to fall, and then worry about the 1 second and how that matters. So for the white ball, S of t is, let's see, we're in feet, so negative 16 t squared. V0 is 0, so I'm going to stop writing that, plus 100. For the blue, S of t equals negative 16 t squared plus 75. And I'll set them both equal to 0 to figure out, because down here at the bottom, s equals 0. S equals 0. So move things around. So 100 divided by 16, and then square root of that. Again with the plus or minus stuff, but it can't be minus, so the white one hits the ball 2.5 seconds after we start the experiment. The blue one move things around. 16t squared equals 75. Thank you. 75 divided by 16, square root of that is 2.165 seconds. But now I got to account for that 1 second delay there on the blue ball. So as soon as, let's say 2.5 seconds from when we start the experiment. But the blue ball, it takes 2.1 seconds to fall, plus the 1 second delay. So it would take 3 seconds from the start of the experiment. We start the experiment, wait a second, and then drop the blue ball. So the white one hits the ground first. That was a tricky one because of that 1 second delay thrown in there.